Distance and midpoint formulas. Let's focus on the midpoint now. You've used the midpoint formula before, and it's commonly thought of as the average x-coordinate and the average y-coordinate. Let's see why. If we have 2 points, P1 and P2, let's say their coordinates are x1, y1 and x2, y2. Well, halfway between P1 and P2, there is some point, let's call it M, that is equidistant. That's the midpoint, right? I'll let its coordinates just be x and y. So the midpoint formula is saying that if you use the coordinates of P1 and you use the coordinates of P2 and plug them into this formula, it's going to calculate an x and a y that are halfway between P1 and P2. So it's kind of interesting that the formula turns out to just be the average of the x values and the average of the y values. That seems intuitive, and a lot of people just accept it because once they see it, they think, oh yeah, that makes a lot of sense, right? But why is that true? In Algebra 2, we've got to prove everything as we go through. So let's see if we can prove this. I'd like to start by making some right triangles in the picture. There's some horizontal lines, and there's some mostly vertical lines. Okay, what do we know about these two right triangles? The red lines are parallel and the blue lines are parallel, right? Keep that in mind. Since the red lines are parallel, P1, P2 is a transversal that crosses them both, so we can say that these two angles are congruent. Similarly, the vertical lines are also parallel, and P1, P2 is a transversal across them as well, so we know that these angles are also congruent. Well, we were given the information in the first place that M is equidistant between P1 and P2, so we also know that these are congruent. And so now we have angle side angle. Let's label these new points also so that we can name those triangles. So the triangles are P1MA and MP2B, and those are congruent. And so all their parts are congruent that correspond. That's going to help us in our proof. So now what I'm going to do is I'm going to use the other parts of the triangles to make some equations using the coordinates, and then figure out if we can prove this midpoint formula. So the first thing I'm going to do is look at those two red lines. Not only are they parallel, but now because they're parts of two congruent triangles, we know that they are congruent as well. The distance from P1 to A is equal to the distance from M to B. We can also say that those blue line segments are congruent, so the distance from M to A is equal to the distance from P2 to B. All right, using those equations, we're going to make equations using our coordinates. Well, we need to name the coordinates for A and B, and we haven't done that yet. So where is A? The x-coordinate for A is lined up with M, so it's x, and the y-coordinate for A is lined up with P1, so it's y1. Now B, let's see, the x-coordinate is lined up with P2, so that would be x2, and the y-coordinate is lined up with M, so it would just be y. All right, now I think all our coordinates are labeled, and we can start writing some equations here. The distance from P1 to A would be x minus x1, since they're arranged in a horizontal line. And the distance from M to B would be x2 minus x. Now let's solve for x, since that's the coordinate of the midpoint. I'm going to move all my x's to the left and move my x1 over to here. Okay, let's see what we've got. We've got 2x is equal to x2 plus x1. And if I divide both of those by 2, you can see that this is pretty much my midpoint formula. Let's clean it up and rearrange it. And there's the x-coordinate of the midpoint right there. Let's try the y's now. The distance from M to A is y1 minus y, and the distance from P2 to B is y minus y2. So let's see, how could we get our y's together and our other things away from that? I'm just going to move that over there, and I'm going to add a y2 to both sides. And let's see what we've got now. y2 plus y1 is equal to 2y. This looks familiar, right? We can finish it off just like we did with the x's and neaten it up a little bit. So y is equal to y1 plus y2 all divided by 2. And there is our y coordinate of the midpoint. And that's our proof of the midpoint formula. Now go use it.